In this video, I'm going to take a look at exam revision for Capture Recapture. Now, Capture Recapture is a topic that goes under the radar, but to be honest, I don't think it's too challenging, or mathematically anyway. All we're really doing is solving equations, but it might be challenging at first when you come across this method if you haven't seen it before. So let's just begin with this first question here, and to begin with, let's just understand what Capture Recapture actually represents. So Capture Recapture is a method of estimating the number of animals in a certain setting. Now, it doesn't have to be animals, but generally the examples you will see represent animals. So like we can see here, I want to work out an estimate for the number of fish in a lake. Okay. So what we'll do is we'll run through this example together, and then there's a couple of practice questions for you to have a go at. So to begin with here, we've got Lauren who wants to find an estimate for the number of fish in a lake. She catches 40 fish from the lake and marks each one with a distinctive die. She then returns the fish to the lake, and she returns a week later. Now let's just consider this first visit here. So this was the first visit. Okay, so this is the first visit. And let's set up a mathematical expression here. So she catches 40 fish from the lake and she marks each one with a distinctive die. But we don't know how many fish are in that lake in total. That's what we want to estimate. Okay, so for the first visit, just call it first here, she catches 40 fish out of the total population, which we don't know what that is. So we represent that algebraically. So we say she caught 40 fish out of the total, which is X. Okay. Then on the second visit, so we'll do this in a moment. So let's just go back to the context of the question. So a week later, Lauren returns to the lake and she takes another sample of 40 fish from the lake. And she finds that 5 of these fish are marked with the die. So on the second visit, she finds that 5 out of 40 have the die. Okay. From there, we want to work out an estimate for the total number of fish in the lake, and we need to make clear any assumptions that we've made. So we'll come back to the assumptions at the end. But what I want to do now is just connect these two expressions. Now, the only way I can do this is to equate both of these. Okay. If on the first visit she caught 40 out of X, and then on the second visit she got 5 out of 40. Okay. What I'm going to do is equate these. So therefore, 40 over X is equal to 5 over 40. Okay. Now what I need to do here now is solve this equation for X. Okay. So the first thing I'm going to do here is multiply both sides of this equation by X, and I'll get rid of this denominator here of X. So therefore I'm going to get 40 is equal to 5X over 40. Okay. Or you can say 5 over 40X. Okay. Now, from here, again, we're just looking to rearrange for X and make X a subject. So what I need to do now is times through by this 40 here, get rid of this denominator, and then we need to divide by 5. And that will leave us with X as the subject. So like I said, we're going to times by 40 and then divide by 5. So to get X here then, X is equal to 40 times by 40, and then we divide by 5. Okay. At this point here, we're just going to put this into our calculator. So 40 times 40, divide that by 5. And what I get here then is 320. Okay. And what that tells us then is that's our estimate. So we're estimating that the number of fish in this lake is 320 fish. So let's just write that our estimate here is equal to 320 fish. Okay. And there we have it. That's our solution. All we need to do now is make clear any assumptions that we've made. And the only real assumption here is that the die hasn't run off the fish, okay, or the die hasn't disappeared, basically. So for the assumption, let's just note that here. So the assumption is the die hasn't gone, basically, okay, or it hasn't run. And there we have it. So that's our assumption. That's our solution for the estimate of the number of fish in the lake. And that gives us the solution to question 1. So we've worked through 1 there together. If you're feeling confident enough, have a go at this question. But for now, we'll work through it together and let's see how we get on here. So for this one, we've got Adam who captures 42 rabbits from his local woodland. Now he marks these by placing a tag on the rabbit, and Adam then returns the rabbits to the woodland. Adam returns a week later and takes a second sample of 80 rabbits and finds that 4 of the rabbits have a tag. So from there, again, we just want to estimate the size of the population of rabbits in the woodland. So let's just consider this in 2 visits again. So we've got the first visit here. So the first visit, then we'll have the second visit. Okay, I'm going to connect those. So on Adam's first visit, he captures 42 rabbits. So we say that Adam caught 42 out of the total, which we don't know. That's what we're going to estimate. So we caught 42 out of X. And it's worth noting here that you don't have to use the variable X. You can use N, you can use Y, you can use Z, you can use whatever you want. But generally, I just prefer to use X. Okay, so he catches 42 out of the total, which we don't know, so we call it X. So that's the first visit. Now on the second visit, he goes back and he catches 80 rabbits, but 4 of the rabbits have a tag. So that's 4 out of 80. Okay. Now again, I'm going to connect these by equating these two expressions. So therefore, 42 over X is equal to 4 over 80. From here then, we just need to rearrange and make X the subject. So multiply both sides by X. So we get that 42. So let's do that up here. 42 is equal to 4X over 80. So again, we're just rearranging here, making X the subject. Times both sides by 80, so, and then divide by 4, so we get that X is equal to 42 times by 80, and then divide by 4. And again, we need to put this into our calculator here, so 42 times by 80, and then divide by 4. And what we get here is 840 there, okay? So what that tells us then is the size, or our estimate for the size of the population of rabbits in the woodland. Okay, so that's our solution there for question 2. And we move on to the final question here. So if you haven't already, have a quick go at this question. Pause the video now, and we'll take a look in a moment at what you should have got. So hopefully you got an okay with this question here. Let's take a look now at what you should have got. So what we've got here is Gemma, who wants to estimate the number of bees in a beehive. So Gemma catches 280 bees, she safely marks the bees and then returns them to the beehive. The next day, Gemma returns and she catches 300 bees, of which 24 are marked. So again, we just want to estimate the total number of bees in the beehive. So let's just, again, consider this in two parts. We've got the first visit, and then we'll have the second visit. So that's the first visit and the second visit here. Okay. So for the first visit, she catches 280 bees, but we don't know how many bees are in the beehive in total. So that's 280 out of X. Okay, again, doesn't matter what variable you use, but I just always use X. And then on the second visit, she catches 300 bees in total, of which 24 are marked. Okay, so she catches 24 marked bees out of 300. Okay. So again, all I want to do now is equate these two expressions. So I'm going to get 280 over X is equal to 24 over 300. Rearrange and make X a subject. So times 3 by X, so I get 24X. In fact, let's keep the 280 on the left-hand side. So I get 280 is equal to 24X over 300. Times both sides now by 300. And then divide by 24. So we get here that X is equal to 280 times by 300. And then divide by 24 here. Okay. Put this into your calculator. And what I get here is 3,500 there. Okay, so the total number of bees, or our estimate for the total number of bees in the beehive, is 3,500. Okay, and that gives our solution to the last question. And that brings us to the end of this video on Capture Recapture. In the next video, we're going to take a look at exam revision for grade 6 topics.